observe the behavior. These are direct transmission, semi-direct transmission, and indirect transmission. In direct transmission, what you do is that you have receiver here, transducer here, and receiver here. You send the sound wave directly into the material, and receiver receives it. And you just have to fed in this length, and the modern instrument will tell you about the velocity, and then you can calculate young modulus with the help of formula I've shown on the second half slide. And in indirect transmission, you use this configuration, and you have to fed in this length because sound is traveling this much distance. And this is indirect transmission. It is highly inaccurate because we cannot measure this distance accurately, and we have to fed in this distance, and it will only give us surface velocity. So this is not very accurate. Actually, while performing the test, pulse velocity method requires smooth surfaces, because smooth surfaces. So if we have two opposite surfaces smooth, we can use direct transmission, which is the most easiest one. And if we have the adjacent sides smooth, then we can use semi-direct transmission. And if we have only one side smooth, then we can use indirect transmission. Basically, what happens in this test, that we know that velocity of sound in air is much lower than the velocity of sound in solid. So when the sound wave passes through the material, it will pass through air voids, which will decrease the velocity of sound. So the young modulus of sound is also, young modulus of material is also decreased. So and strength is also decreased. So this method is quite useful in quality control to determine the quality of different concretes and reinforced materials. This was all from my side. Now I would like to call Mohsin Rafi to tell you more.
Thank you so much, Ahmed. Assalamualaikum. My name is Mohsin Rafi, and I will be talking about the concept of range and how to determine the depth of the claw using ultrasonic testing. And along with this, I will also be telling about the rail inspection and the well defect in the railroad. So starting off with the testing of aluminium 2024. This is a sample of aluminium 2024, and this was prepared on a demand in the workshop. So these are the reference peaks which you can see on the slide. The first peak is due to the tasting, and we are getting a backward echo at approximately 5.2 division here. And actually the range on the CRT was set to 50 millimeters. But as you can see, the sample is only approximately 20 millimeters. So we are getting a backward echo at 5.2 division. And 30 divided by 5.2, we get 5.76. That means one division is equal to 5.76 millimeters. So this was a short concept of range. Now coming on to the determination of first and second crack and all the cracks that are present on the material. As you can see, the first crack, we are getting a small peak right here. You can see the small peak, very small peak. This is on the first crack, as the crack is very small, and we are getting the crack peak at 1.2 division. That means 1.2 multiplied by 5.76, we are getting approximately 6.9 millimeter, and that is the depth of the first crack. And same goes for the second crack and the third crack and the fourth crack. The peaks which you can see here after the backward echo, like for example, this is the third crack, we are getting a peak at approximately 1.1 division, and then the backward echo. After it, we are getting some peaks here. These are due to calibration errors and due to some noise. Now I will be telling about rail inspection. As you know, there are many applications of the ultrasonic testing, and one of a very wonderful application of ultrasonic testing is rail inspection. It can prevent the failure of railroads and can save us from many accidents. Nowadays, the inspection is automatic, so that large amount of crack can be tested in short period of time. And the method used nowadays is two-wheel method, like you can see in the picture here. By two-wheel method, we mean that the first wheel, which is the leading wheel, these emit the ultrasonic waves which enter the specimen and are reflected back from the bottom surface. And these reflected waves are caught by the second wheel, the wheel that is behind the leading wheel. And this is connected to a control, and the control then displays the information of the railroads. Now here is a close view of the wheel and the rail track. You can see in the wheel there are transducer, and the transducer will emit the perpendicular wave and the transverse transverse waves. Like you can see, these are the transverse waves and these are the perpendicular waves emitting normal to the railroad. Along with this, you can see that you are able to determine the transverse head crack, and along with these you are able to determine the bolts hole crack. So many of the cracks, longitudinal cracks or the transverse cracks, can be detected very easily. And one more thing, the wheel is filled with water, which will obviously act as a couplant. So now coming to weld inspection. As you know, the rail tracks are welded together, and obviously there would be some shortcoming in it due to lamination, inadequate fusion, cracks, etc. flaws. So the basic principle behind the weld inspection is to determine the defects of the weld. And we are using an angle beam producer here with the principle of refraction. You know that the angle beam producer technique is the shear waves enter into the specimen from the side, and the transverse crack can be detected very easily. Nowadays, phased array system is used to know about the weld inspection. We have a short video for you as well of a phased array system. Please have a look at it.
So just what is RailElect? Well, it's a collaborative project funded by the EU and research organisations
This is basically a whole phased array system.
The benefit of a number of small to medium enterprises. They have a common objective: to develop a clamp-on ultrasonic testing device for examining aluminothermic rail welds. As you see here, aluminothermic welds are performed in situ, trackside, and involve plenty of heat, light, and sound. But they're not infallible. If a weld breaks, then a repair must be undertaken, and that disrupts traffic and is very costly. The need for RailElect arises from the fact that weld breakages do occur shortly after manufacture where there are flaws in the weld. And that's what this piece of kit is designed to detect. There are 4 specific aims of the project, and they are to
telling about phased array system. It consists of a phased array probe that has a frequency of 2 megahertz to 10 megahertz, and it consists of elements ranging from 16 to 256. And these elements are arranged in the form of a ring, and they are capable of sending the ultrasonic wave and then catching the reflected waves back. So these echo are plotted on the display so that we can know about the location of the cracks. And one more useful aspect of the phased array system is whole of the data can also be stored. And in phased array system, we obtain a graphical view of the welded part. Now, and you may know that if you are obtaining a graphical view, it is very easy to know about the lamination, the inadequate fusion, or the cracks, etc. And now over to Mr. Daud.
Ultrasonic testing has evolved from the conventional apparatus used in our laboratories to much more advanced and compact devices, such as the thickness gauges shown in the picture. Conventional magnetic and eddy current gauges only work on metals, leaving ultrasonic testing as the most reliable method for measuring thickness of plastic layers. Ultrasonic coating thickness gauge is a non-destructive device which measures the thickness of plastic coating. The standard test method is described in ASTM B1630204. The range of this device is from 13 to 1000 microns. How does this device work? This device works by sending an ultrasonic pulse into the material by a probe, by action of a couplant. The couplant from rough surfaces is commonly water-based glycol gel. For smooth surfaces, even a drop of water can act as a couplant. Pressing down the probe indicates the specified reading. Advantages of such gauges over other non-destructive testing methods include: they are quick. Non-destructive measurements can now be taken on materials that previously required destructive testing. Minimize waste by controlling thickness of coatings being applied. Simple to operate, and last but not the least, affordable and reliable. There are many applications of such gauges, and a few of them are described as measuring the total thickness. Many plastic coatings are applied in a number of layers to achieve the desired result. These gauges can measure the total thickness of such layers. Application 2. Measuring rough coating surfaces.
Coating with rough surfaces provide problem for any testing method, and ultrasonic is no exception. On rough surfaces, the gauge identifies the thickness from the top of the coating to the substrate, that is distance 1. Everything is done to minimize error. Severe roughness can cause the gauge to display lower thickness values, that is distance 2. This is because the intensity of the echoes from the substance coating interface are much stronger than that of the coating substrate interface. But however, the gauge has a user-built gate which permits that the roughness echoes are to be neglected and the gauge displays a true result, that is distance 1. Application 3. Measuring individual layer thickness in a multi-layer system. The ultrasonic coating thickness gauge is capable of measuring up to 3-layer individual thickness in a multi-layer system. Such measurement using the apparatus in a lab is very difficult, since the peaks for the individual layers will probably coincide. Application 4. Automotive parts. Cars have a number of components made from plastic, both in the interior and exterior. Ultrasonic coating thickness gauge is an effective method of measuring the thickness of such components. Our presentation concludes that ultrasonic testing is one of the most versatile form of non-destructive testing and has many other uses rather than detecting flaws. And considering the amount of development going in this field, the best is still yet to come.